Hi students, this is T. Balakrishna, Chemistry Lecture, GPT KOTHAGUDEM. Today our topic is uh, batteries. What is battery? Galvanic cell is a source of external energy. Galvanic cell is a source of electrical energy in which chemical energy of redox reaction is converted into chemical energy. Galvanic cell is a source of electrical energy in which chemical energy of redox reaction is converted into electrical energy. That means which cell is generate which batteries generate the electricity by the spontaneous oxidation reaction is called galvanic cell. So which cell is convert the electrical energy into chemical energy into electrical energy is called galvanic cell. Two more electrochemical cells connected in a series is called battery. That means connecting of two or more galvanic cell. Galvanic cell also called as electrochemical cells. Electrochemical cells. So that means connection of two or more galvanic cell or two or more electrochemical cells is called battery. A container consisting of two or more cells in which chemical energy is converted into electrical energy is called battery. So what is the difference between cell and battery? Both are generate the electricity, both are galvanic cells. So it is in a cell, it is in a battery. You observe this battery is contain one anode and one cathode. One anode and one cathode. It is also generate the electricity, but it contain one anode and one cathode. Come to the battery, it is also generate the electricity, but it contain many number of anodes and many number of cathodes. So here many more than two cells are connected in series manner. So connection of many number of galvanic cells or electrochemical cells in series manner is called battery. A cell consisting only one anode, a cell is consisting the cell contains only uh, one anode and one cathode, whereas battery contains many anodes and many cathodes. There is a main difference between cell and battery. Both are generated electricity by the spontaneous oxidation reduction reaction. But batteries contain many number of anodes and cathode. That means many cells are connected in series manner. Come to the battery, it contain only one anode and one cathode. Is it clear? So both are generated electricity, but in cell it has only one anode and one cathode. In battery, it contain many number of anodes and cathode. Next one. Here batteries are cells, whatever it is. Batteries are divided into two types. One is the primary battery, another one is the secondary battery. Come to the primary battery or primary cell. uh, uh, Primary cell means it contain only one anode and one cathode. Primary battery means it contain many number of anodes and cathode. uh, uh, the cell in which the electrode reaction uh, can't be reversed by passing an external electrical energy is called primary battery. A battery or cell in which electrode reaction cannot be reversed by the passing on external electrical energy is called primary battery. In primary cell or primary battery, the reaction occurs only once, and after use over a period of time, battery become dead and cannot be reused again. So it is not chargeable. The which battery or which cell is not chargeable, that type of cells is called that type of batteries is called primary batteries or primary cells. Is it clear? Once we use the battery, we can't recharge it. Once we use it, use in through bat cells or use in through cells, we generally use it. Once we are used, we can't be uh, reverse reactions in electrolyte cell, we can't be recharged. Such type of cells or batteries is called primary batteries. uh, once we use the battery, battery become dead and cannot be reused again. That means the battery uh, that means cannot be reused again, so it is not rechargeable. Example for this type of battery: zinc carbon battery and mercury battery and dry cell. These are the example for primary cells or primary batteries. They can simple remember it using of it not chargeable. It not which battery or which cell is not chargeable. Such type of batteries or cells is called primary batteries or primary cells. Next one, secondary batteries or secondary cells. The battery in which the electro reactions can be reversed by passing on external electrical energy is called secondary batteries. Okay, the which cell or which batteries act as an electrochemical cell or electrolytic cell. The which cell is act as electrolytic cell and electrochemical cell, that is called uh, secondary battery or secondary cell. The which batteries act as electrolytic cell and electrochemical cell. This act as a electrolytic cell and galvanic cell. So once it generates the electricity, so that cell is called galvanic cell. When we supply the electrical energy, it is act as a electrolytic cell. So which cell or which batteries act as a electrolytic cell and electrochemical cell? That cell is called, that battery is called secondary battery or secondary cell. It is uh, the secondary cells once the secondary cell can be recharged by passing electrical current and used again and again. That is the main difference between cell primary battery and secondary battery. uh, so secondary battery is uh, recharged by passing electrical current and used again and again. The secondary cells are also called as storage cells. Secondary cells also called as a storage cell. It is chargeable, and also a secondary battery is known as storage batteries because we convert the we store the energy by it when the cell is act as electrolytic cell. It is act as a storage battery. After it is a galvanic cell. Galvanic cell means it generates the electricity. It stores the energy and it reverses the energy. Okay, so what is the difference between main difference between primary and secondaries? Primary batteries are not reused, so can't be reused again, so it is not chargeable. In secondary batteries or secondary cells, it can be chargeable and used again and again. And in the secondary cells or secondary battery, we store the electrical energy. This electrical energy is coming to uh, mechanical energy, whatever it is, we use it. Okay.
Okay, we discuss about the working of lead storage battery. Working of lead storage battery. So in this lead storage battery, lead is act as a anode, lead oxide is act as a cathode. Lead is act as a anode, lead plates are act as a anode, lead oxide plates are act as a cathode. Working of lead storage battery. First one is the lead storage batteries act as a galvanic cell or voltaic cell. That means it generate the electricity. When the lead storage cell is operate as a voltaic cell, that means galvanic cell, that means it generate the electricity. The following reactions are takes place. So in this process, uh, lead is act as an anode and lead oxide is act as a cathode. సో వీ నో ద మనం ఆల్రెడీ నేర్చుకున్నాం ఆ ప్రిన్సిపల్ ప్రకారం యానోడ్ దగ్గర ఎప్పుడైనా ఆక్సిడేషన్ రియాక్షన్ జరుగుతుంది. సో హియర్ ఇక్కడ లెడ్ దగ్గర ఆక్సిడేషన్ రియాక్షన్ జరిగి జరుగుతుంది. క్యాథోడ్ దగ్గర రిడక్షన్ రియాక్షన్ జరుగుతుంది. లెడ్ దగ్గర యానోడ్ రియాక్షన్ జరిగి పీబీ+2గా కన్వర్ట్ అయ్యి 2 ఎలక్ట్రాన్స్ రిలీజ్ చేస్తుంది. తర్వాత పీబీ+2 SO4-2తో రియాక్షన్లో పార్టిసిపేట్ చేసి పీబీSO4గా కన్వర్ట్ అవుతుంది. తర్వాత ఎట్ క్యాథోడ్ క్యాథోడ్ దగ్గర PbO2 రిడక్షన్ రియాక్షన్లో పార్టిసిపేట్ చేసింది. కాకా ప్రిన్సిపల్ రిడక్షన్ రియాక్షన్ కాబట్టి క్యాథోడ్ దగ్గర రిడక్షన్ రియాక్షన్ కాబట్టి సో PbO2 plus 4H plus ions plus 2 electrons giving rise to PbO2 plus 2H2O reduction reaction. Next overall reaction Pb plus PbO2 plus 2H2SO4 giving rise to 2bSO4 plus 2H2O plus electrical energy. It is discharge reaction. సో ఈ రియాక్షన్స్ గుర్తుపెట్టుకోవడానికి నేను చిన్న ఎక్స్ప్లెనేషన్ ఇచ్చే ప్రయత్నం చేస్తాను. సో రియాక్షన్స్ గుర్తుపెట్టుకోవడానికి చిన్న కోడింగ్ గుర్తుపెట్టుకుంటే సరిపోతుంది. సో ఇట్ కంటైన్ యానోడిక్ సెల్ అండ్ యానోడిక్ PB is act as anode, PbO2 is act as a cathode. So PB is act as a anode, PbO2 is act as a cathode. Okay, is it clear? So in anodic anodic electrode, what reaction takes place? Pb is converted into PbSO4 and cathodic part PbO2 also is converted into PbSO4. Next, the electrolyte is H2SO4. What is the percentage? 20 to 21%. So this part is act as a anode, this part is act as a cathode. It is in a galvanic cell. In galvanic cell anodic part and cathodic part are there. So anode and cathode. So it is a cell notation. ఈ సెల్ నోటేషన్ తెలిస్తే మనం ఈజీగా రియాక్షన్ రాయొచ్చు. ఓకే, సో what are the reactions at anodic part? At anode so at anode Pb is converted into PbSO4. Pb is converted to PbSO4. Pb is converted to PbSO4. Okay, right? So how to confirm this in oxidation reaction? Here Pb is element. What is oxidation state? 0. In PbSO4, SO4 is a -2. You know the oxidation state of sulfate, SO4 -2. If it is SO4 -2, what is the oxidation state? +2. Here Pb0 is converted to Pb+2. That means Pb is converted to Pb+2. When it is converted into Pb+2, when they are released the 2 electron. So here Pb is converted into PbSO4 by releasing of 2 electrons. Is it clear? Pb is converted into Pb+2 by releasing of 2 electrons. So it is a first reaction. Here Pb is converted into Pb+2 by releasing of 2 electrons. What is the name of the reaction? Oxidation. What is the name of the reaction? Oxidation. The name of the reaction? Oxidation. Is it clear? It is very important. But Pb is converted into Pb+2 by releasing of 2 electrons. Oxidation reaction. It is an anodic part reaction. Okay. Next, to come to the cathodic part reaction. Come to the cathodic reaction. PbO2 is converted into PbSO4. So PbO2 is converted to PbSO4. It is a trick to remember the cathodic reaction. So here PbO2 is converted to PbSO4. So PbO2 is converted to PbSO4 means it has one sulfate. So sulfate ఇంతకుముందు చెప్పడం మర్చిపోయాను. ఈ రియాక్షన్లో ఇక్కడ మనకి ఇక్కడ SO4 ఉంది కదా, ఈక్వేషన్ బ్యాలెన్స్ చేయాలంటే ఏం చేయాలి? ఇక్కడ SO4 minus 2. So Pb is react with SO4 minus 2, giving us to PbSO4 plus 2 electrons. ఈ SO4 ఎక్కడి నుంచి వచ్చింది? మనకి ఎలక్ట్రోలైటిక్ సెల్లో అదే మన సెల్లో లెడ్ స్టోరేజ్ బ్యాటరీలో ఎలక్ట్రోలైట్ కింద ఏం యూజ్ చేసాం? సల్ఫర్ని యూజ్ చేసాం. కాబట్టి సల్ఫర్లో H+ అయాన్స్, SO4 minus 2 అయాన్స్ ఉంటాయి. కాబట్టి దాంట్లోనే SO4 minus 2 అయాన్స్ని ఇక్కడ Pb గెయిన్ చేసుకొని PbSO4గా కన్వర్ట్ అవుతుంది. సో ఇక్కడికి వచ్చేసరికి PbO2 కన్వర్టెడ్ టు PbSO4, Pb ఈస్ కన్వర్టెడ్ టు PbSO4. ఈ PbSO4లో ఇక్కడ SO4 ఎక్కడి నుంచి వచ్చింది? ఫ్రమ్ ది ఎలక్ట్రోలైటిక్ సొల్యూషన్, SO4 minus 2. So PbSO4. So Pb react with SO4, it convert into PbSO4. నెక్స్ట్ ఇక్కడ ఆక్సిజన్ ఉన్నాయి కదా, దీన్ని న్యూట్రలైజ్ చేయడం అంటే కెమికల్ రియాక్షన్స్లో స్టైకియోమెట్రిక్ ఈక్వేషన్లో ఈక్వేషన్ బ్యాలెన్స్ ఉండాలి. నెంబర్ ఆఫ్ రియాక్టెంట్స్ ఇస్ ఈక్వల్ నెంబర్ ఆఫ్ ప్రొడక్ట్స్ ఉండాలి. సో ఇక్కడ ఆక్సిజన్ ఎక్కువగా ఉంది. 6 ఆక్సిజన్స్ ఉంటే ఇటు 4 ఆక్సిజన్సే ఉన్నాయి. సో ఆక్సిజన్స్ అటు రావాలి కాబట్టి ఇక్కడ it react with H+ ions. How many number of H+ ions? 4 H+ ions. 4 H+ ions. 4 H+ ions. Here 4 H+ ions plus O2, it gives 2H2. It gives 2H2O and it gain 2 electrons. It gain 2 electrons. It is a reduction reaction. It is a reduction reaction. It is a reduction reaction. Okay, it is an oxidation reaction. Is it clear? So I write the reactions once again. At anode reaction, at cathode reaction. At anode Pb is converted to PbSO4 by releasing of 2 electrons. So reactants and products and ఉండాలి కాబట్టి ఇట్ సల్ఫైట్ రాస్తాం. ఇది ఆక్సిడేషన్ ఎలా కన్ఫర్మ్ చేస్తాం? ఇట్ ఈస్ అన్ ఆక్సిజన్ స్టేట్ is 0, here oxygen state is +2. Here Pb is 0 is converted to Pb +2 by releasing of 2 electrons. So it is oxidation reaction. Okay, come to the cathode reaction. At cathode PbO2 is converted to PbSO4. So it is contains sulfate ion, so include sulfate minus ion, SO4 minus 2. When balance the equation, product reactants are 2 ఆక్సిజన్స్ ఎక్కువగా ఉన్నాయి, తక్కువగా ఉన్నాయి కాబట్టి దీన్ని రీప్లేస్ చేయడం కోసం ఇటు సైడ్ నేను ఏం చేస్తానంటే 2 వాటర్ మాలిక్యూల్స్ రాస్తాను, 2H2O. అప్పుడు 2 ఆక్సిజన్ బ్యాలెన్స్ అయిపోయి కానీ ఇక్కడ నీకు 4 హైడ్రోజన్స్ ఉన్నాయి. 4 హైడ్రోజన్స్ ఉన్నాయి కాబట్టి ఏం చేస్తాను? 4H+ ionsతో రీప్లేస్ చేస్తాను. ఓకే, ఇట్ ఈస్ ఎ బ్యాలెన్స్డ్ ఈక్వేషన్. ఓకే, ఇట్ cathode reaction, it is reduction reaction. Okay, the overall reaction, anodic reaction, cathodic reaction. Okay, so it is electron, it is reduction. How to confirm it is a reduction reaction? It gain 2 number of electrons. PbO2 gain 2 electrons. It is connected to Pb minus 2. This Pb minus 2, okay, sorry, Pb plus 4, it is converted to Pb plus 2. It react with SO4 minus 2, it is converted to PbSO4. So next one, here it has 2 electrons and 2 electrons cancel. Okay, remaining are cancel అవ్వాల్సినవి ఉన్నాయా, ఏం లేవు. ఓకే, PB. So PB plus PbO2 plus 4H plus ions plus 1 plus 1 2 sulfate ions, 2 sulfate ions giving rise to PbSO4 and PbSO4, 2 PbSO4 plus 2 H2O. Okay, here one H2SO4 is contained 2 H plus ions and 1 sulfate ion. So it has 4 H plus ions and 2 sulfate ions, nothing but 2 H2SO4. So if you want to write this reaction in simple, Pb plus PbO2 giving rise to 2 H2SO4 giving rise to 2 PbSO4 plus 2 H2O, and also it will generate the electrical energy and also produce the electric. It is a voltaic cell, it generate the electrical energy. This is a discharging reaction. This is a discharging reaction. So after some time it may noted that the lead sulfate is participated at the both the electrodes and H2SO4 is used up. So concentration of H2SO4 is decreased. If the concentration of H2SO4 is decreases, the battery does not generate the electricity. So then you recharge the battery. We discuss about the we already discussed discharging. Discuss about the discharging. Next we discuss about the recharging. In this recharging process, anode is act as a cathode, cathode is act as anode. So at cathode in recharge process, the cell can be charged by passing electrical current, then reactions are reversed. As a result, Pb is formed as a cathode. In recharge reaction, Pb is act as anode. Pb is act as anode, but in recharge reaction, Pb is act as a cathode. PbO2 is act as a anode. So, but reactions are reversed. You change the name at cathode and write the ఇక్కడ cathode అని రాసి ఇదే రియాక్షన్ రివర్స్లో రాసి సరిపోతుంది. at anode అని చెప్పి రాసి ఇదే రియాక్షన్ రివర్స్లో రాసి సరిపోతుంది. Compare these two reaction. It is a discharge reaction. Here cathode is Pb, here anode is Pb. It is a recharge reaction. Here cathode is Pb. Is it clear? Cathode is Pb. Okay. In discharge reaction, at cathode is PbO2. Cathode is PbO2. In recharge reaction, anode is PbO2. Okay. So just లేబుల్ మారిపోతుంది. యానోడ్ దగ్గర క్యాథోడ్, ఎందుకంటే రివర్స్ రియాక్షన్ యానోడ్ క్యాథోడ్ అవుతుంది, క్యాథోడ్ యానోడ్ అవుతుంది కాబట్టి సో జస్ట్ హెడ్డింగ్స్ మారిపోతాయి, రియాక్షన్స్ రివర్స్ రాస్తే సరిపోతుంది. ఓకే. సో అట్ క్యాథోడ్ PbSO4 plus 2 electrons giving rise to Pb plus SO4 minus 2. At anode PbSO4 plus 2H2O giving rise to PbO2 plus 4H plus chance and SO4 minus 2 plus 2 electrons. It's an oxidation, anode oxidation. Is it clear? So ఆ ప్రిన్సిపల్ ఏం మారదు, కాకపోతే యానోడ్ క్యాథోడ్ అవుతుంది, క్యాథోడ్ యానోడ్ అవుతుంది. సో రియాక్షన్స్ ఎలా రాయాలో గుర్తుపెట్టుకుంటారు కదా. ఇవే రియాక్షన్స్ అంటే మీరు డిశ్చార్జ్ రియాక్షన్స్ రాస్తే రీఛార్జ్ రియాక్షన్స్ రివర్స్ రియాక్షన్స్ అవుతాయి అంతే. Okay, that is working principle of lead storage battery. Thank you. This is T Balakrishna, chemistry lecturer, GPT Kothagudem. Thank you.